Hello and welcome to the CellNetAnalyzer tutorial. In this video we will compute elementary modes. We will normalize the modes, select and save subsets of modes that satisfy specific conditions. We will plot the yield distribution, the 2D yield space, and a histogram of the pathway lengths. Finally, we will compute their corresponding minimal cut sets. First, we compute the elementary modes for anaerobic growth on glucose. Therefore, we load a predefined scenario. We click Scenario, Load Scenario, and choose Glucose Standard. To ensure anaerobic growth conditions, we disable the reaction for O2 uptake by entering 0 in the corresponding text box. When calculating elementary modes, all reactions with a predefined reaction rate of 0 are excluded. To calculate the elementary modes, click Analysis, Elementary Modes and Pathway Analysis, and Compute Modes. In the Elementary Modes dialog, click Start Computation. The first elementary mode is automatically displayed in the network map, and the control panel for the elementary modes comes up. We can navigate through the set of elementary modes by clicking the Next and Previous button. We want to normalize the modes with respect to the glucose uptake rate. Therefore, we choose Normalization of Modes in the Statistics pull-down menu, and click Compute. In the field Reaction to which the modes will be normalized, we enter the glucose uptake reaction. Next, we want to check whether there are elementary modes that do not include the glucose uptake reaction. Therefore, we click on the Selection button and enter the glucose uptake reaction as a reaction that must not occur in selected elementary modes. We click OK, and now there are two elementary modes selected that do not include glucose uptake. Next, we want to delete these two modes from the set of elementary modes, because they are thermodynamically infeasible cycles. First, we select again all elementary modes. We click the Select All button. Then we click the Selection button. This time we enter the glucose uptake reaction into the field Reaction which must occur in an elementary mode. Now we have the inverse selection of 61,810 modes. By clicking the button Delete Unselected Modes, we remove the remaining two modes that do not include the glucose uptake reaction. As a result, 61,810 elementary modes remain. All of them include the glucose uptake reaction. We save these modes for later analysis. We click the button Save All Modes, enter a file name, and click OK. Next, we plot the yield distribution within our set of elementary modes. Therefore, we select Yields and Rate Ratios in the Statistics pull-down menu, and click Compute. We enter the names of the product excretion reaction and the substrate uptake reaction, and click OK. The yield distribution within the set of elementary modes is shown as a graphic, and more information is given in the command window. Next, we select elementary modes with a maximal ethanol yield per glucose. Therefore, we again select Yields and Rate Ratios in the Statistics pull-down menu, and click Compute. We enter the names of the product excretion reaction and the substrate uptake reaction. This time we additionally enter a 2 into the field for minimum yield. This selects only these elementary modes that have at least a ethanol yield of 2. We click OK, and now 33 modes are selected. We select again all elementary modes. Next, we create a 2D yield space plot. Therefore, we select 2D yield space plot in the Statistics pull-down menu, and click Compute. Then we specify the yields to be displayed. For the x-axis, we enter the biomass yield per glucose. and for the y-axis we enter ethanol yield per glucose. We click OK, and a plot of the distribution of the elementary modes in the two-dimensional yield space is shown. Next we compute the path length of the elementary modes. Therefore, we select Pathway Length in the Statistics pull-down menu, and click Compute. A histogram of the path lengths among the elementary modes is shown. Next we select the elementary modes that have a path length of at most 20. Therefore, we click the Selection button, and enter 20 into the field Maximum Number of Participating Reactions, and click OK. As a result, 42 elementary modes are selected. We could now further inspect this subset of elementary modes. Next we want to compute all minimal cut sets that block biomass synthesis in E. coli. First we select again all modes, then we click again the Selection button. This time we enter growth as a reaction that must occur in all elementary modes, and click OK. Now 59,259 modes with a growth rate bigger than 0 are selected. To compute the corresponding minimal cut sets to these elementary modes, we select Minimal Cut Sets in the Statistics pull-down menu, and click Compute. Calculating the minimal cut sets is a computational demanding task. Therefore, to accelerate the computation time, we enter 3 into the field of maximum cut set size, then we click Start Computation. We can check the progress of the computation in the command window. 334 minimal cut sets with a maximal size of 3 have been found. The control panel for the minimal cut sets comes up, and the first minimal cut set is shown in the network map. The disabled reactions of a cut set are shown in red. Note that CNA also finds the trivial cut set that deletes the biomass reaction itself, which is shown as the first result. We can use the Next and Previous button to navigate the cut sets.